Imagine you're a ticket collector on a train. Let me draw my best train here. A little chimney, old school train. And let's say you're the ticket collector and you stand up here with the conductor. Now, the job of a ticket collector is to go through each passenger car. These are amazing passenger cars. And collect all the tickets of each one of the passengers. Now, of course, there may be one passenger in the car. There may be 10 passengers in the car. We're not sure. Now, of course, a car can actually hold more than just passengers. A car could hold luggage and everything else like that. But for our purposes right now, all we're going to talk about is the passengers. And that ticket conductor, their job is to go through the train and collect each one of the tickets from each passenger in the car. Now, of course, that conductor has to follow a few physical rules in order to do their job. So, for example, the conductor, since they're starting at the front of the train, must work their way towards the back of the train. The conductor, or sorry, not the conductor, the ticket collector. The ticket collector cannot just jump across automatically to the third train, or to the third car. He doesn't know. Doesn't even know if that car exists, because all that ticket collector can do is see the car directly in front of them. That car is blocking every car behind them. It's a very horizontal structure, so the vision isn't even there. So that's not possible. Secondly, once the ticket collector is in a given car, let's say they get into this first car here, the collector can only collect the tickets of the passengers in the car. He can't call across to the next car and say, "Hey, throw me your tickets." Not only is that rude, it's not really feasible. These are paper tickets, can't really throw them. So, not possible. The interaction between cars and their cargo is our goal today. So we're going to be looking at saying, okay, if we have an individual car that has cargo in it, now that cargo could be passengers, it could be luggage. In the world of programming, that cargo could be anything. It could be strings, could be integers, could be collections, could be all sorts of different things, objects. It doesn't really matter. The point is that there is some form of cargo, and there may be more than one piece of cargo. What we want to do is, how can one car how can we get from one car to the next car? And in order to do that, we set up a system very similar to the train. This link. Each car only has one link in front of them, or behind them, and says, you know what, I can connect directly to that next train car. So as the ticket collector is going through, he gets to an individual car and looks to say, hey, is there another car back there? Yes, all right, I better go get the tickets from that car. If there isn't, he's done his job. He doesn't have to go any further. So that we create this similar system inside of our programs, and we draw an arrow from one car to the next car. So the system of linking one car to another car, in which each car holds its own cargo, is what we call a linked list. A linked list, similar to an array or a list, is a data storage structure. Its job is to store large amounts of data, not single individual pieces of data like a regular primitive variable. That's not its goal. So the way that linked list works is that as a program, our main program, instead of holding a whole collection in a single variable similar to an array or a list, all the driver class holds is just the first car. That's it. That's all it has. That's all it can see. Just like when the ticket collector is in the front of the train, if the train is like our driver class, all it can see is that first car. It doesn't even know if there are any other cars. So it ignores the fact that they exist. In order to get to the next cars, it's got to go in that first car. And then it can look and say, hey, is there another car? If there is, then the ticket collector can go on. The key here is that the driver class does not hold a whole collection. The driver class only holds one single car. In programming, we call these cars nodes. A node. So that, in its most basic form, is what a linked list. In the next video, we're going to talk about why we should use linked lists, what are the powers of linked lists, and the differences between arrays / lists and linked lists.